Welcome back to the studio. I hope you had a very good break, especially those who are now torturing Marcus for questions and getting the good responses back. Please do use our speakers who are available to you over the chat channels that we provide and get as much information as possible out of them. Now, the next speaker is going to be from a switched CERT, from the Switzerland CERT. Martin, and he is going to carry on the talks about what we have. We have introduced already the operational technology in industrial control systems. We've introduced how to capture stuff over the network and identify what is bad. Now Martin will look at this and combine these two things together and look at how to capture something bad within operational technology networks. Martin, welcome to the studio. The cyberspace is yours.
Thank you very much. Yes, exactly. So I think we are all already warm, especially after the last talk from Marcus. I continue kind of similar topic, of course, network packets and everything like that. We're gonna see how that works in industrial networks or industrial environments. So for that, I like to, I should have a quick agenda to see what we go through. We have 40 minutes, so it's quite long, or 45 minutes, quite long. So I try to entertain you, that is not too boring. Short about myself, I did apprenticeship in electromechanics, then went to the university, there I did automation, then was many years around the world doing commissioning, programming industrial control systems. And then 2017 with NotPetya, I got into the security field. And as introduced, since 2019, I'm working for Switch. Switch is a non-profit organization in Switzerland, looking after the education network and as well the internet domain space.ch and LI. And also we have like a small CERT where we, you can imagine students, they like to click on many things. So we look after the security in our network and as well critical infrastructure like power generation, industry, logistics, and also banks. So, and my part in there is network security monitoring, of course, but also everything around operational technology. And as we don't sell something as a switch, I like to mention the PLC security top 20 list, where it is for secure coding of PLCs. You can look it up in the internet and find some coding practices how to program a PLC. But now back to the security monitoring. First, quick introduction where we are, what is industrial control system, or nowadays with operation technology. To set the environment. So we have industrial environment, can be a bit harsher than in the office, like temperature-wise or from vibration, dust, all these type of things. And then what industrial control is doing is measuring something like a temperature here, and then adjust something like a heating. So when the temperature outside is low, then the heating needs to turn on and heat your house, or in the industrial plant need to heat for some process. Then looking from security point of view, we have also the CIA, as you know, from normal IT with availability, integrity, confidentiality. And in the industrial world, we also have a safety. Safety is for, of course, human operators around the machinery so that nobody get harmed. Safety is also for the environment, that the environment does not get polluted, and safety is also for the machine itself, that it doesn't get destroyed by bad operation, or if something goes wrong. When taking the example of the heater, that the heater is not overheating and then get destroyed. So safety availability together is often combined and listed under control. Me as an operator of my industrial plant, I want to have control over my plant. So I want to be able to turn it on, but I also want to be able to turn it off. So that was for very long time the main objectives. But nowadays we also have to look at integrity, and of course depends the industry, but also confidentiality, especially when you think about personal data, is getting more important. So that is kind of the environment where we are, the security objectives. And next, I want to talk a bit about the evolution in industrial control systems regarding connectivity, because also nowadays a lot of times people kind of saying, oh, but why the industrial plant is not secure, why we have so many vulnerabilities, and why PLCs are still in terms of security not where they should be. And for that we need to look at the evolution. And here it started all with relay control many years back in the 1900s, when the electricity was introduced, and then goes into in the 1960s, 70s. We have the first PLCs when microcontroller came up, and already there we have also first communication over wire, if you want to say, like a bus system. You might know the RS-232, something similar like that is already like very long time ago available. So connectivity is not something new in the industrial environment. It is long there. And then, of course, when the personal computers came up, servers came up, this also took place in the industrial world. We got HMIs, like a human-machine interface, these touch panels you might know, then servers, and of course operator stations, which nowadays are normal PCs running Windows operating system on it. But what changed in the last years is we have increased connectivity towards the office, let's say, or ERP. You know, like you want to have the production data in real time, also in your ERP system, and of course, everything should be available on the cloud or in the internet as well. So, like the customer like to see how much energy he used in the last month. So for that, he goes to a internet web portal and enters his username, password, and then can see what he used. So this is something which was changing in the last years, this increased connectivity, and this is also creating some troubles, because like all these many years before, the PLC was not meant to be like so much interconnected with other systems. Yeah, they were like closed, or they called us air gap networks. But nowadays this is not the case anymore. And with that, of course, we have also the security. We have to take care of it, and network monitoring is one of the element which can help you to stay secure, to stay safe, and run operation as you want to. So on the next slide, also what we need to think about when we talk about industrial control system cybersecurity, you need to think about what is available on your side, what you have in terms of experts, professionals, and that is often quite difficult. You might have the IT department where you have like full-time, of course, personnel. You might even have a security operations center. But if you then go to the industrial side, then it gets more difficult. And so here, when we look on the network monitoring, we are in the upper right part, where you also have a SIEM, or you have like log collection. That means you almost would need to have full-time on-site industrial control system cyber operation personnel. And in most of cases, except if you're a big organization, you don't have personnel for this type of operation. So this is a challenge we also face in Switzerland, and we try to overcome this challenge by introducing network security monitoring and start with very small steps in a very low level. So we don't introduce a tool where we say, okay, now this is your tool, nothing to do anymore, and you are safe or secure. No, it doesn't work like that. We try to integrate technicians, electricians into this evolution so that we can take them one step further, that they at the end also understand what is going on in their network. Then also what you have to take into account for network security monitoring, it is a mitigation control. It is something where you see when something happened already. Yeah, it doesn't mean that the consequence is bad, but something must have happened that you can see it in the network. And here also, if you have some security budget, then maybe also think about to invest that in preventive controls, like everything before something happened. So like make sure that your PLCs or industrial devices are not directly like available or to be contacted from the internet. That your industrial devices are not on the same network than your office computers. All these type of things, you really should take care as well, because preventive is all the time better than after, when already something happened. Also in the industrial world, what we like is quite old, the Purdue model, but I think it is still valuable to discuss and to kind of put into perspective where we are and what we are talking about, and also in terms of the network security monitoring, which protocols are used. So at the bottom, at level 0, we call it the field level. There you have all the sensors, all these actors, like measuring, taking temperature, and motors, valves, conveyors, all these type of things running there. And nowadays it can also be Ethernet, TCP/IP based, like with Profinet, for example, but often is still like a 2-wire bus, like a Profibus, which is very common in Europe, or Modbus in the American industry. Then if you go up level 2, level 1, 2, 3, that can be sometimes difficult to distinguish which level is now what, but there you have almost 100% Ethernet-based protocols like Profinet, or then OPC UA, or in the power generation, the IEC 104. And then if you go further up, you get more into the office world, where you have, like in your office network, SMB, for example, or HTTP, or still the OPC UA, depending how it is set up. So there you also see that the model got expanded over time. We have with level 3.5, the DMZ was introduced, because connecting the office and your industrial network together is not a good idea. So you should have something in between to separate your networks. Then another point which is maybe different from the office protocols, we have in the industrial protocols the Ethernet-based one. There can be some, they are time sensitive, so something which need to be real time depends all the time, like in which context. But if you think about drives like motors which need to be synchronized, for example, in a paper factory where you have the paper going through the machine, so all motors transporting this paper, they need to be in the same speed, otherwise the paper will break. And this is time critical, if you want to say. So you need some protocols which are fast enough. And there, Ethernet or then TCP/IP is not fast enough because is not enough deterministic. You know, it depends how you load this on the network. The message might arrive a bit earlier, a bit later. So for this type of application is not good enough. But in most, for most application it is okay. You also see that we have Profinet or here OPC UA, IEC, they all have IP TCP or UDP based, and then on top the application layer. If you're working with safety over Ethernet, then this is just implemented as black channel, means the payload of your TCP packet is then filled up with the safety protocol. This is still also something I would say under progress, work in progress, because as you might know, safety is important to for personal safety or to control your process. And if you have an interruption or somebody might manipulate the values, the result is not like what you want. So we need to pay attention to this as well. So now looking at the network security monitoring, you might ask, okay, yeah, all nice, how do we do it, or why even should we do it? There are like 4 main things I would like to highlight. So when you start with it, what you will see first a lot are configuration errors. You will see stuff which devices which are not correctly configured. For example, the time setting of a device. We regularly find like devices were set to 1970, you know, like really the possible beginning of the Unix time. And of course, the system still works, but if you need to look deeper and try to understand, it is not helpful when you have a different timestamps, and then you cannot really correlate. Then, of course, performance. You know, sometimes you might have some issues that the system is not behaving as intended, and often then you find out that there is a problem in the from the network performance. For example, if you have some data which is going over GSM, that line might not be appropriate when you have on the other side a video camera sending a live stream, and in the same time you have also your control system, the commands and measured values, they go also over this same channel, then it's just not enough. So this type of things you also will see. Then of course you see health, the status of your network, meaning if a device is not responding anymore, then you will also see that in the monitoring. And what, of course, from security point of view, what we all kind of look after things not belonging there, like a virus or somebody opening a website which should not be opened. Now, when you look, of course, on the market, there are many commercial products available. You can buy them. They are covering all these different topics, like, of course, asset discovery. Why? because most of the network owners, they might have a list where with all the assets and IP address in, but in real world, the list is never complete. So you have your list, but yeah, it's not complete. So with the asset discovery, you first get your list complete, and then of course you need the management of it. So like when new devices come on the network, turn on, then you need to add them to your asset. Then of course network monitoring they do, but then also they do anomaly detection, vulnerability management of all the devices in the network, and threat intelligence feed, like all these vulnerabilities found almost daily. They kind of curate that in the feed, so you don't have to look after this information you can find on the internet from vendors or the CISA who put them together. Then also now they started to do the version control of the PLC application, so that you can make sure that what is running in the PLC is the latest version. Nobody changed it. The firmware on the PLC is also the version you think it should be there. So nobody changed it on the way. And already from the list, you can see this is quite a lot. And that's why in the beginning, I mentioned for the personnel, if you have such a tool, you need dedicated personnel for it. You cannot let it run just like that and think, okay, I will have 1 or 2 alarms per week, and then I look after them. And that's it. It doesn't work. And beside the personnel you need, they also are quite expensive. For a small or medium-sized company, as I know, is very difficult that you can put it into your budget and buy this software. So that's why we were looking at the open source market. Open source field, not market. As before, Seek, Suricata was mentioned already. Then you might know the Security Onion, which is also under quite a strong development. They are a very strong community. Snort, which is a long time software. And then we have Malcolm, is quite new, is something put together. I think it's also Seek in it. And then we have ntopng actually, which is also a monitoring software coming out of the pure performance monitoring market, but now got extended with cybersecurity elements. We had, when we were evaluating it, this is a very rough evaluation, but we were thinking, okay, so now who is using this software? And the personnel using it, they are electricians, they are PLC application engineers. Important, they are not network engineers, and they are not Linux or Linux or Windows engineers. They of course they can operate on a computer, but to install a software or then do configuration, that is out of their scope. So that's why when you see on the setup and installation, Security Onion, for example, is a very good tool, but it has kind of a high, you need to get familiar with it. It's a collection of tools, and if you're not familiar with the field, or like for electrician, it might be overwhelming. Similar with Suricata Seek. Just to have Suricata and Seek doesn't give you a graphical interface, so you cannot look in a graphical way see, okay, now I have these and these alarms, or this is going on in my network. Yeah. So this is kind of what is available. But for me, most important is not to fall into the toolitis, which or how we call it. because with many tools you can do the job, and the tool is not the main important things. Of course, some tools maybe help you more, some less. But yeah, at the end is you need to start with one, and for us we selected ntopng because it has some advantages. As I said, it's easy to install, easy for the operator. Like with the predefined alerts, for example, he doesn't need to learn the syntax like you know from Elasticsearch, for example, or from Splunk. Of course, it's not as advanced like it would be in Elasticsearch or in Splunk, but it doesn't matter in the beginning. Because what we want to do is to get you started with network security monitoring, also in the industrial environment, because that is even more like a black spot on the network map than it is in the office environment. So where to start? First thing is kind of let's think about, so what, when we look at the network, what do we want to see, what we expect to see? So we have this like before also I mentioned misconfiguration, for example, or we have not allowed traffic or unusual traffic, and that we see malicious traffic is very rare, or hopefully we don't see malicious traffic. But we also need to think what we will do when we see some anomaly in our network. And that is the left part, like what we want to see, is called like use cases, and the right part, what I will do when I see it, that is they are called playbooks. And you don't have to invent that for yourself from the scratch. There are already very good examples out there. For example, from the BSI, the German how say government institution, they are doing these general use cases, and then put together industrial control system use cases. So if you can check all that, like okay, I can detect all this, then you're done. Then you have the first part successfully completed. Of course, also for the playbook, there are examples out there. So like the playbook is then more what you will do when you see an alert, like kind of, okay, do I need now to turn off the network, or I still can carry on? This is defined in a playbook. But in our recommendation is choose one use case, really just one. Don't think or go further, because otherwise it's overwhelming. Beside the configuration error, you will find out there's not much space for more than one use case. I like normally to start with to look after remote support software, because this can be in industrial environments a bit a headache, as every supplier uses a different system or different software to remote support their equipment. I mean, at the end is if you're an asset owner, is your equipment, but you know they are using different techniques. Also, you might use internally maybe one of these solutions that you can access from remote to your network and control the machines. So we say okay, remote support software like the known ones like TeamViewer, or remote desktop protocol from Microsoft, or AnyDisk, VNC, but there are many more. And then to start with, we say okay, now which computer, which host is using that, and which ports are used for that, or if like external communication is necessary for that, which domains are used by this software, remote support software. TeamViewer, for example, you will see in the DNS that the TeamViewer server is contacted to start your remote support. So when you look at it, which hosts are using or talking remote support software, you will find maybe there are many, maybe not, depends a bit the size of your network. But when you start to look at it, you can figure out, okay, so now I have one host here. This one is talking on the left side, is talking to many different. Then I have some, maybe there are just two computers like connected to each other, or in the middle, in the bottom, where you have the thicker line. That seems like to be heavy used connection over the router. Yeah, so you get the impression from this service map, like where you see RDP is used by these hosts. Now, that to go further with that is like the next, we call it baselining. So you need to understand what is normal in your network, and that can be quite complex, because when you first look at it, many things many things going on, and you're not sure is now this something good or not. So don't is a lot of work, but don't get frustrated, because when you start to look at it, you will learn to understand your network, and with that, at the end, you will own your network, and that is a big advantage, which will help you in the future. This is all still not really depending on the tool. You can do this even with Wireshark if you want, maybe a bit more difficult, but any tool which can show you what is going on in the network can help you for that. So now when we go a bit further for industrial protocols, it gets maybe difficult more, or just has some different characteristics. So for example, this IC 60875.104 is like also like a very old protocol. It was used to run over two-wire, like RS484 before, was then ported into TCP/IP, and now is just running inside TCP/IP. But what is different for if you compare it with IT communication, you have these long single flows, like between two devices or between server and client, you can have a flow which is running for days. Because that is part of this protocol is opening like one flow, and then inside this flow, the data exchange or the communication is happening. And compared to the IT part, there you have almost every communication or data exchange is a new flow. So you will see many flows in the IT side, less flows in the industrial network. And with that, if you think about that, when you want to know what is going on, then you also need to have a DPI functionality, the packet inspection, because you need to be able to look into the payload of your TCP packet. So that I want to show you at this example, because then, yes, you need to go a bit into the protocol itself, and you will figure out that, okay, like what I just mentioned, the flow information is not enough, because then inside the TCP payload, there is where things are happening. So in the industrial world also, it can be one packet, it can be enough to turn on or turn off devices. So with the security monitoring, as said, is mitigation control. So I might be too late to do something, but I still can alarm, or I can later on use the information to figure out the root cause of the malfunction of the plant. So without going too deep into it, you see you have like some control fields, you have some address fields and so on. That is like one data package, I would say. The difficulty is a bit, you can have multiple of these data packages in one TCP packet or in one TCP payload. And even inside one of these data packages, you can have like multiple sub data packages. So if you want to analyze it, you need to be able to pass the protocol like kind of in a loop type of in a loop type of way. Why I mention it is because when you work with SIG or Suricata, it is mostly like signature based. And as you can imagine, if I have one APDU or two APDU, then the signature is not same. So I cannot have a general signature for that. I really would need to loop through my TCP payload to see what is going on. Otherwise, I'm just on flow level. I had to see who is talking to whom. Maybe I can figure out the frequency or like how often they talk to each other, but I cannot see further down. So in the ntopng, we implemented that with the IC 104. So you get additional information. You see it on the top right in the info field. You see like what is going on in each packet. Of course, this is just a general information. You cannot see every packet because the system, I mean, the update frequency is not as fast. But we have it mainly there because some flows are only there for like the redundant path. Yeah, we have this test frame which is sent forth and back on the redundant path. So you can filter the list, of course, and then when you have one host, you should have the main path, which is communication with S and I, as you can see in the example, and then you have the redundant path with the U test frame. What we also did, that is for those interested in cybersecurity, yeah, like the Ukraine events, there they used some not seen commands before. They call type IDs, and we are monitoring type ID transition. So we see like, okay, we have from command 36 goes back to 36, but then it can also be 37, 37. So we check how the system is in normal operation, or again, baselining. I need to know what is normal, but once I have done it, I'm sure that is now all okay. Then I can check, okay, from this point on, in the future, when something is not as it was before, I do issue an alarm. And then you see this type of alarm we have there, and yeah, further on that, then the operator can see what he needs to do. So with that, oh, sorry, that was too fast. Now I am actually at the end. It just got the most important. Doesn't work. Sorry. Okay. I go back to it again. Yes. No. Yeah. Now, yes. Give it a try. That's the most important message from my talk. Try to start with the network monitoring. Look into what is going on into your network. And if you have questions or later on something is not working, I'm happy to answer, happy to help. You can find me on LinkedIn or Twitter, or of course now in the Discord channel. With that, back to the studio.
Yes.
I don't know who is saying.
Yes, welcome back to the studio. So thank you for the presentation. I'll have a discussion with you now. I know you're an expert. We are both on the same information exchange group for the industrial control system security, specifically for energy sector. Now, I'll start with a very high level question before drilling down in depth, but the high level question is still a very complex one, maybe. So Industry 4.0, industrial IoT, shift to the cloud. How do we monitor this? I mean, you're focusing towards the open source community, open source tools being used. Is that something that's applicable? What's your take on this?
Yeah, totally. Maybe the question is more like for encrypted traffic. We have now in industrial networks, we have not so much encrypted traffic. It's still like everything clear text, if you want to say. So point of view of network security monitoring is an advantage, but of course it's not good practice to have it clear text. So, and if you start to communicate with the cloud, then I really hope it is encrypted, but it doesn't matter that much. You know, of course, you can then not see anymore inside which commands are going forth and back, but towards the cloud, I would say it's more the business type of information which is going there and not your plant control information. And still with ntopng or like other tools as well, you can extract quite a lot of information without breaking the encryption. Like I don't like to how you say, like break the encryption, you know, because then I make the weak point somewhere else. I like to see the flow, who is talking to whom, amount of data, for example, like even a nice example is all the time SSH, you know, you log in, you want to exfiltrate some data, so you can see that in terms of number of bytes which are going from external to internal and what is going from internal to external. So there are still some possibilities to see and then understand what is going on in your network.
Right. I understand fully that like multi-layered approach towards the network, separating the streams and controlling the streams, that they are within that particular segregated area is one of the key aspects. Now, when we look at the open source tools,
Yeah.
do they always will fit in everywhere in all of those segments, like really down to the industrial control system area where you have field devices, or they will be mostly maybe applicable to higher levels? And do they comply with industry standards? Maybe that's also a question that might be out there.
Yeah, that is a very good question where I have it here. Yes, all, as far as I know, all open source network monitoring tools, they start from IP upwards in the OC model. Yeah, IP, then TCP or UDP upwards, like network layer 3, as you can see. So you cannot monitor like time sensitive protocols. And of course, Profibus as a two-wire bus, all the other ones you have here on the left side, you can also not monitor just out of the box. And there is where the commercial products they have, of course, they also you can with them also monitor CAN or Modbus or Profibus. Yeah.
What would you say? There is a technological restriction, or that is just industry has to kind of figure the way? I mean, because I would understand that in essence it should be possible, but what is the blocking point that we're facing currently that's stopping us from low level interaction and kind of analyzing of the protocols? That's too much information?
No, I would say mainly work. You know, you have to implement all these protocols and sometimes maybe also the like physically how it is running over the wire. You know, that is if you look at Profibus, is maybe not as easy as it is on a TCP/IP network to monitor. Of course, it's still possible, but then you need additional equipment for it, and it's just way more, how you say, work to do, way more, you need also equipment for it. And we often make the experience that when you start with network monitoring, to start slowly and with, as like I said, one use case, to not overwhelm the operators. And yeah, we also see the other one. If you go with a commercial product, they start very optimistic, and then they they have the product running, and then comes the baselining, and then the optimism goes down over time. Sometimes even have to restart the setup because the use cases were not properly defined.
Right.
And, yeah.
I know I've been working on IEC 104 for a long time, but that's not the only protocol out there, right? This is just one of. You've been focusing on that one. Let me just quickly take a stab at this one, that protocol as well, from the network intrusion detection system perspective. Now, as you clearly stated, it's a single TCP stream. It can be very lengthy. It's typically unencrypted, although encryption protocols, security standards exist, but they would not be implemented. Now, the IDS has to be, for me as an attacker, I can change just one bit to kind of turn the switch off. Now, the IDS has to be context aware if this is a malicious packet or malicious frame, and how to target this. Is that something that current IDSs can already handle? Getting this context, hey, this is a malicious command, or we're still heading that way?
Yeah, we have, when you look at the protocol itself, we didn't go that deep down yet. We go down until the type ID, as I said. We look at this, that one, and then we have the ASTU address fields. We also look, but we don't look into the. We just haven't implemented it deeper down. Also, like what I in this context, what I like to bring up is, I mean, if you want to do some attack on the network, like man in the middle, or somehow you want to manipulate the data, you need to get into the network itself. So of course the system is also checking for new MAC addresses coming up on the network, or new IP addresses. It is checking for DHCP servers, like if there's a rogue DHCP server or NTP server, all these type of services you have in the network, it is checking. And so already there is, it all the time depends how difficult, but it's a hurdle to get into the network at all, So you cannot just plug in, okay, I have my computer now and I change something in the packet. You might get detected before already.
Right. I mean, the cases have been out there that typically it's either an insider threat or either it's supply chain integrity, which makes our life really hard to capture those malicious events. There is no silver bullet for this. We know that for sure.
Unfortunately not. And until you get there, that you can all detect that, that your system is running that nicely, that you have almost no false positives, unfortunately, it's a long way to get there, especially in the industrial environment. I think, as you know, the systems, they grow over time. So you have very old equipment running beside very new equipment. And it has to run for a long time, like 20, 30 years, So it's quite difficult to get down to such clean baselining that you can say, okay, now I really have all done, and now I can look at this type of anomalies.
Right.
Also certificates, for example, like now we're starting encrypted traffic in the industrial network. Most how I say integrator, they use then certificates, but then they forget like to renew them, or they use one certificate on different servers, so it doesn't match neither. And all that you see after in the monitoring, but it's then also a lot of work to get it clean up. So it just adds more complexity.
Right, but that's why we still have a job, right? There will be always
Sure.
thing what to do, right? And I
Yeah.
think there is still a lot of things to take care of. I mean, building the security ground up, when understanding security, when designing the networks, and having it in place.
Yeah.
Martin, thank you for the talk. Thank you for being here in the studio. If there are any questions, please catch Martin in Discord. Thank you so much.
Thank you too.
And with this, we are nearly coming to the end, but please don't run away, because in the next talk, the next speaker is going to explain how to take control over the cloud. You might be interested in this, so stay tuned. We'll be back in about 10 minutes.